This is a tutorial for instructional purposes only. We'll be examining a Nand Gate system. What we have here is a hardwire circuit hooked up to 5 volts, 1 k ohm resistor, switch A, B, and a lamp. Right now, in the present state, you could tell that electron flow goes through and the lamp will be on. Once switch A and switch B closes, electron flow goes through this direction, turning off the lamp. Right here is the logic symbol for a NAND gate, basically an AND gate with a little dimple, making it a NAND gate. For switch A and this is switch B, same thing here, A and B. This is an AND gate with an inverter, making it a NAND gate. This right here is truth table. We'll use this to help illustrate exactly what's happening in this truth table. In other words, when A is not pressed, B is not pressed, you get an output on the Y, electron flow goes through. When A is not pressed, B is pressed, you still get a 1 on the Y, electron flow goes through. When you press A is pressed, B is not pressed, you still get electron flow going through. When A is pressed and B is pressed, electron flow does not go through, so there's a 0 on the Y. This right here is a 7400 quad 2-input NAND gate. Right here on pin number 1 would be switch 1, pin number 2 would be switch B. The output would be the Y. This is the same chip that's in here, so if we hook this up, immediately turn on. When we press A, it still stays on. When we press B, it still stays on. But when we press both, it turns off, proving this. Now right in here, this is a PLC programming of a NAND logic gate. Right here is an examine if open instruction for push button 1. This is an examine if open instruction for push button 2. Right now, well, this is also the pilot light. Since this instruction, you could when you see this instruction, you can ask yourself, is the addressed contact, the push button 1, is the contact open? Right now we have 2 closed push buttons addressed to each one of these. One push button here, one closed push button here, one closed push button here. When you see this symbol, you can ask yourself a simple question. Is the addressed contact open? Since it is closed, this is a false right now. Same thing for here. Is the contact open? No, it is false. It's a false instruction. So, when you push the button, ask yourself, is the contact open? Yes. That becomes true, allowing logic continuity through, turning on the lamp. Or, if you push this button, since this is an examine if open instruction, you ask yourself, is the contact open? Once you push the closed push button open, it becomes from a false state to a true statement, allowing logic continuity to flow this direction. So, this is the state of the normally closed push buttons will be false when they're closed, but when you press it, it opens and it becomes true, allowing the light to turn on. This right here is an example of the same thing, but with a control relay, bit relay, in between, right here. Right now, this is an examine if open contact, since the bit has not received any high statement or turned on. This will be true, allowing logic continuity to turn on the lamp, similar to what's happening here. The push buttons that are addressed to these two are normally open push buttons. This is push button number 3, and right here, this is asking, this is a normal examine if closed instruction. You can ask yourself a question: is the contact closed? Right now it is normally open, so this is a false situation. Same thing here. Examine if closed. Ask yourself, is the contact closed? No, it is open, so this is a false statement. So when you push the button, it goes from a normally open to normally closed. Examine if closed. This goes to a true statement. Same thing here. Examine if closed. Is the contact closed? It goes to a true statement, allowing logic continuity to flow through to this control relay. It's a bit relay addressed to number 3. Turning off this examine if open. Is the contact open? No, the contact is closed now, so this becomes a false statement, turning off the lamp. And that's how to understand a NAND gate system.